Am I audible?
Yes, sir.
Okay, the screen is visible, the white screen.
Yes, sir.
Okay. So that today we will start with the thermal relays. Thermal relays are actually thermal relays. These are actually, you can say that these are bimetallic type, and they work on, these are bimetallic type, and the main idea is that they work on the principle of strain generated due to unequal linear expansion of two different metals. Of two different metals. Now, what it means? It means that we have the two different metals in this type of relay. We will have the two different type of metals. So let us suppose that this is the base of that, and we have the two different metals. Let us suppose that this is, let it be AB and CD. So we have a wire which is wound across it, and this current is flowing through that particular wire, and this part is actually connected to the trip contacts. That is, we will have this one, then after that we will have this one. These are actually the trip contacts. You can say that these are the trip contacts. Now, what happens? It is actually a bimetallic strip. Like it to have, we have the two metals in that, that is AB and the CD. Now, if you see, whenever the current flow through this wire, the both these strips AB and CD, it gets heated up by the same amount, but it get heated up. The heat is same, but the expansion is different because they have the different coefficient of the linear expansion. It means that if you see, CD part has the higher coefficient of the linear expansion. Now, what it means that if the same current is flowing through these two metals, then in that very case, the heat is generated. However, the expansion in case of this CD is more as compared to that of AB. So as you know, the heating effect is proportional to the square of the current. So energy dissipated in that very case is also proportional to the square of the current. So what happens when this is the coefficient of linear expansion of CD is more than that of A, this AB, as a result, what happens? It expands more. Like if you see, it expands more like that as compared to inner one. And with that, what happens? These strip contacts, whatever is given, this strip contacts will get connected together. So the main idea is nothing, but we have the two metals and we have the wire which is wound around the two metals, and the coefficient of the linear expansion of this CD is more than that of the AB. And as a result, because of this heat generated in that, it will get tripped out. So this is the main mechanism of this kind of, you can say, uh, this kind of relay. Now, if you see, actually the accumulation of sufficient amount of heat depends upon the thermal inertia of the relay, which tends to be large. These relays are used where very quick operation is not required. If you see, if you take the case of this if you take the case of the quick operation is required, let us suppose the fault occurs in the system, then we cannot provide the quick operation in that very case, because it's very difficult, because it is based on the fact that bimetallic strip get heated up for this you can for sufficient amount of time. So the the protection for which the main application for which it is used for the overloading of the motors. It is used for the overloading of the motors. So what happens? Whenever the overloading is there, and we can allow the sufficient amount of time for the overloading. Let us suppose the 20% overloading is there, and after that, it is still heats up the system still heats up, the relay heats up, and after a sufficient amount of time, it becomes closes the drip contacts. So you can say that thermal overload relay lets the motor supply overload for a sufficient amount of time. Now let us discuss in detail some of the features of this thermal relay, so you can have the basic idea of this kind of relay. So first point is that these are required to protect the equipment against the overload condition. Against the overload condition. Now, second point is that this actually how this overload condition occurs. The overload condition occurs many times during the operation of an electrical equipment. Operation of an electrical equipment. And if you see any of the electrical equipment that we are using, it has ability to withstand the overload condition for a definite period of time. So any equipment has ability to bear the overload for some time, that is sufficient amount of time. It means that for sufficient amount of time, it can take the overload. So it depends upon the, you can say that it depends upon what type of equipment that we are using. So what do you mean by overload? What do you mean by overload? Let us suppose that we have a transformer and which is rated, this transformer is rated for, you can say, 100 ampere current. This transformer is actually rated for the 100 ampere current, and let us suppose that if the overload condition occurs in that very case, it means that you can, in a 100 ampere case, it means that it can take this 100 ampere current continuously without any temperature rise. It will take this current without any temperature rise. Without any temperature rise. So it will take the current, this 100 ampere current, it is the rated current of the transformer, without any temperature rise. Now let us suppose that we have a current of 105 ampere. We have a current of this 105 ampere, you can say that this increase in the current, that is gradual. You cannot say that it is very fast. If it is very fast, then definitely it is a fast fault. It is not a overload. So it is gradual. धीरे धीरे वो increase होगा current ना. So again, if let us suppose that 105 ampere, let us suppose that the current increases to 110 ampere, though 100 ampere is the rated current in that very case. So this gradual increase in the current, rated value of the current, is increase in the current above the rated value, which is known as the overloading of the equipment. Or you can say the gradual increase in the current above the rated value, gradual increase in current above the rated is actually known as the, you can say that it is known as the overloading of the cube. So in case of the overloading of the equipment, you have the gradual increase in the current. धीरे धीरे जो current है वो increase होगा. So that condition is known as the overloading of the equipment. You can say what technical parameters is affected during the overloading. It is only it is the current which is affected during the overloading. So if we consider the case of the fault, in that very case, the current increase is not gradual. You can say it is very rapid. So that's the difference between the overloading and this, you can say, the faulty condition. Now let us suppose the rated current of is of same value, that is 100 ampere, and if the current, let us say, becomes 200 within a fraction of seconds. So out from the 100 ampere, let us suppose the current becomes within the fraction of seconds, it becomes 200 or 300 amperes or 1000 amperes. So you can say that it is known as the fault. Because you must know the basic difference between the overloading condition and faulty condition, so that you can devise the logic based on that, so that as a result you can develop your own relay based on that. So this is basically the difference between this overloading condition and this, that is the current becomes 2 or 3 times or 10 times, and in that very case. However, if you see, if you take the case of the thermal relay, if you take the case of this equipment, any equipment, it can take the overload for a sufficient amount of time. However, greater be the overloading, lesser be, you can say, lesser be the withstand capacity of the equipment. Now let us suppose that we have one table is there. We have the percentage of overload with respect to full load, percentage of overload with respect to full load, and time to withstand that overload. Time to withstand that overload. Now, let us suppose that if the percentage increase in this condition is 120%, then it will, you can say that it will continuously bear that. It will continuously bear that. Then we have the 140%. Then in that very case, it will bear that for an hour. Then if it is 150%, then in that very case, for half an hour, then it is 160%. Then it will bear for some minutes, or you can say for several minutes. And if it is 170%, then in that very case, for a few seconds. So it gives us the information that what is the percentage increase in the current and for how much it can bear that. So this is the main idea is that greater be the overloading in that, lesser be the amount for which it will remain there. So you can say the characteristics of thermal relay should exactly match with the characteristics of the equipment that we want to protect. So thermal relay requires the longer time, usually in you can say seconds or sometimes in minutes, and also maybe few minutes compared to the overcurrent relay. So we can discuss that, which actually means that for the protection of the equipment against overload, which is a rapid phenomenon. So you can say the difference between this thermal relay and the overcurrent relay is that the overcurrent relay is rapid. It operates within a fraction of seconds. It operates within a fraction of seconds, or sometimes you can say milliseconds. And the thermal relay, on the other hand, the thermal relay, it operates in several minutes or seconds, depends upon the increase in the current, value of the increase in the current that we have discussed. So this is the basic difference between this overcurrent relay and the thermal relay. The basic difference is that the overcurrent relay, it will operate in seconds or milliseconds, and the thermal relay operates for several minutes, because thermal relay is based on the fact that the heat is generated in a case of the bite metallic strip. So now the question comes that why in earlier case also, a few times ago, you can say a few decades ago, the people are using the thermal relay or the bimetallic strip in that very case, and they are actually utilizing the remote temperature detector also. They are utilizing the thermocouples or thermosensitive devices for that. But the main disadvantage of this thermal relay is that is their resetting time. The main disadvantage of any thermal relay is the resetting time. Now, what is this resetting time? So we can discuss that resetting times and what is the resetting time. Now, let us suppose what happens. Suppose this thermal relay operates. Let us suppose that our thermal relay operate. I am suppose the transformer, we are using the transformer, and this thermal relay trips. For a transformer, let us suppose this thermal relay trips. Now what happens? So now what happens that if the relay trips, and let us suppose this transformer is out of service. Let us suppose that we have a transformer connected to this. And let us suppose some fault occurs in the transformer, and if the thermal relay trips, and it will isolate that particular circuit. And what we want, we want to restart the transformer or reconnect the transformer. So in that particular circuit immediately. So we won't do that. Why wouldn't do that? Because it depends upon the resetting time of the relay. It depends on the resetting time of the relay. And if you take the case of this thermal relay, so thermal relay is basically depends upon the heat generated. So we want to again start that equipment. We cannot do that because that particular relay is very hot. So it is the hot start of any equipment is difficult in that very case. So you can say that the hot start is difficult. That is, we want to energize the transformer again after the fault, but and we have used the thermal relay. So what happens that thermal relay still is in the hot state, and still it is actually deformed because of the linear expansion, and we cannot restart it again. It takes some time to cool. So that is known as actually the resetting time. The resetting time of this kind of relay is very large. That's why it has minimal applications. It has the applications only in the overloading condition. It cannot have application in this where very you can say that immediate start is required. So that's why nowadays, recently, you can say nowadays what we are using, though thermal relay we are using for some applications. However, if we want the application of this that thermal relay, we can use the digital or the numerical relay. We are using the digital or numerical relay. So in that, you can say that in digital or the numerical relay, it is a universal relay. We have the features of thermal relay in that. That is, all the features of thermal relay are in that, and whatever the time we want to fix, that is available in that, and it can trip in a fraction of second. So that principle, that type of relay, we are using this. Nowadays, we are using, if we want the thermal relay for some operation, then in maximum of the cases we are using the digital or numerical relay. However, for the overloading conditions, still we are using this thermal relays. So because of the issue of this resetting time. So you can say that this digital or numerical relay, it will provide the resetting time of nearly 0.1 to 0.2 seconds. So in 0.1 to 0.2 seconds, it will reset. Now that is the nowadays we are using. However, for the overloading condition, we are still using that thermal relay. Now, this you can, if you take the case of this thermal relay, so this we can compare this thermal relay with MCB also. This thermal relay also contained in the MCB nowadays we are using. So if we compare, let us suppose we compare the thermal relay with the MCB, miniature circuit breaker. Then you can say that that is, we are using the miniature circuit breaker for a domestic application, as you already know. And if you look at the circuit of the MCB, if you take the circuit of this MCB, miniature circuit breaker, so the miniature circuit breaker is in that very case, if you see, it contains the two elements. One is some instantaneous device, and other we will have the bimetallic strip that is used in the thermal relay. So first is the instantaneous this device, and second is the bimetallic strip that is used as the thermal relay. Now, what happens? Let us suppose the magnitude of the current is high. Let us suppose that we have the rated current of 2 amperes, and if the current exceeds the this rated current, in that very case, you can say if the magnitude of the current is you can say less than the time times the rated current, that is 2 ampere, then the whole of this, you can say, MCB will operate instantaneously due to this instantaneous device. It means that if the magnitude of the current, let us say 10 times, let us suppose we have the current of 2 ampere and magnitude of the current becomes this 20 ampere in a very small amount of time. In that very case, what happens? The whole of the MCB operates instantaneously. That is a MCB instantaneous device, which is within the MCB, it will operate. Now, let us suppose that the magnitude of the current is 3 or 4 ampere. Let us suppose the magnitude of current is 3 or 4 ampere. Then in that very case, the instantaneous operation is not provided in that very case. Now, what happens? In that very case, the bimetallic strip come into picture, and as a result, and depending upon the this bimetallic strip, it operates. So MCB consists of the instantaneous device and the bimetallic strip. Now, as you know, the basic idea of any thermal relay now, as you know, the basic idea of any thermal, this you can say heat generated. So heat generated in any electrical equipment is given by I square RT, and heat dissipated, let it be denoted by TD. Now the equilibrium temperature, what happens? The heat generated equals to heat dissipated. It means now, what it means that our device is made in such a way that if the rated current is flowing, let us suppose the rated current is 10 ampere. If the 10 ampere current is flowing in that very case, what happens? The heat generated is equal to heat dissipated. That heat generation in that very case is more than the heat dissipation. However, if the current is if the current is more than that, in that very case, the heat that is generated is not equal to heat dissipated, and as a result, we have you can say the this it cannot withstand that. That is during the normal loading of an equipment is this equilibrium temperature, that is TE, is actually well within the temperature withstand value, and which depends upon the insulation level, because we have provided the insulation level in such a way that it is within the you can say that it is within the temperature bearing, it has the temperature bearing capacity of that, and if it is more than that, then definitely it will not be possible. That is, we have the insulation level within that. And as you know, with withstand value or limit that is decided by the type of the insulation. As you have already read that there are different types of insulations. I think you have read in the machine design. So different types of insulations, that is A to H type of insulation. So these kind of insulations are available. And if we consider the type or the class of insulation, then for any winding, the class of insulation are this available from A to H. So we move. So there is a class type A of insulation or class type B of insulation that is available, and each kind of insulation depends upon the current that is carrying capacity of that very particular equipment. So, if you can say the time within which the temperature of the equipment, time within the which the temperature of the equipment exceeds the temperature withstand value of insulation is inversely proportional to the value of the load. You can say the time within which the temperature of equipment exceeds the temperature withstand value of insulation is actually the inversely proportional to the value of the overload. So it means that the time that is required within which the temperature of equipment exceeds the temperature withstand value of the insulation, it depends upon the overload. What is the overload in that very case? And it is inversely proportional to the overload. And if you take the case of, if you draw the graph between this time and this, you can say the overload, that is in terms of current, it would be somewhat like that. If you draw the graph between the time and the overload, then in that very case, it would have the inverse characteristics. And this is the characteristics of the equipment. This is the characteristics of the equipment, or you can say the thermal withstand characteristics of the equipment. This is the thermal withstand characteristics of an equipment. And if we take the case of the relay characteristics, if we want the relay characteristics in that very case, the relay characteristics would be like that. That is, the relay characteristics would be below this thermal withstand capacity of an equipment. However, we will try to optimize that, because in that very case, this is the relay characteristics. And if the relay characteristics, that is, the equipment can bear the temperature up to that, and if the relay characteristics is here, in that very case, the much of the this space is wasted in that, and we cannot utilize the whole of the potential of that particular equipment. So we can try to fix the relay characteristic near about this thermal capability limit of that particular equipment, so that you can have so that not much of the space is left in that, so that we can have relay characteristics such that it will near about this thermal this withstand capacity of that particular equipment. So one more point is that if you take the case of this, this is the point which is related to the thermal relay. So one point is that this thermal relay is actually used for the overloading of the equipment. So you can say the overcurrent relay, it cannot be used for the overload protection of the equipment. Overcurrent relay, it cannot be used for the overload. It cannot be used for the overload protection of the equipment. So this overcurrent relay, it cannot be used for the overload protection of the equipment. This is due to the fact that overcurrent relay cannot exploit the thermal withstand capacity of the equipment, as it you can say it operates in the range of the milliseconds. That is, it cannot explore, you can exploit the thermal withstand capacity of an equipment. of equipment. So it cannot withstand the thermal withstand capacity of the equipment. So this is how we can use the characteristics of the relay that we try to this characteristics of the overload relay near about the equipment thermal withstand capacity of the equipment. And if you take the case of this characteristics of this, you can say the overcurrent relay. The characteristics of the overcurrent relay is near about this point, because what we have to disconnect the equipment in a fraction of milliseconds, you can say. So if the equipment, let us suppose that if the equipment, this is let us suppose the characteristics of the overcurrent relay, and we suppose that if the equipment is capable of taking the overload for a certain amount of time, and we use these characteristics, so still we have to operate, we will operate the equipment up to this point. So I think this is not, you can say, beneficial for the equipment as a whole. So in that very case, you can say that this overcurrent relay is used for the transient operation, and the overload is used, and this or thermal relay is used for the this, you can say that during the overload operation. Now let's have some basic structure of this this thermal relay. I told you the basic concept. We have the bimetallic strip in that. So let's have the basic structure of this thermal relay. Now, in case of the thermal relay, what we have. Here we will have the bimetallic strip. It is made up of two metals. This is actually known as the relay contact. This is the bimetallic strip. Then you will have here we will have the heating coil. And this information, this is heated up by the CT from the current from the CT of the secondary terminal, CT secondary. And this is actually the heating coil. Then you have a structure is there. You have used spring. And this is going to the trip circuit. So, as I already told you, the thermal relay consists of the bimetallic strip. Thermal relay, it consists of the bimetallic strip made up of nickel alloyed steel. Nickel alloyed steel. So these are heated by the element that absorbs the output of the current transformer, if you take the case. Now, at one end of this bimetallic strip and insulated arm with the trip contact is provided, and the arm is connected to the spring which provides the tension against the closing of that particular contact. So this is the basic about this. This you can say that this information is coming from the CT of the this information is coming from the CT of the secondary, which is connected to whichever one we want to protect the this equipment. And if you take the case of the operation under the normal operating condition, the bimetallic strip, if you take the case of this bimetallic strip, it remains in the straight position against the action of spring tension. And when the overload condition is detected in that very particular case, let us suppose the overload is 120% or 140%, then the rated current, the bimetallic strip, this bimetallic strip, it will bend and allow the trip contact. It will actually bend and it will allow the trip contact. This will bend and it will allow that particular trip contact. So what are the applications that I have already discussed? That applications, it is used for the low voltage and the low power rating. It is used for the low voltage and low power rating induction motor. Low voltage and low power rating induction motor are an NDC motor. And where in that very particular case, where the resistance temperature detectors, that is RTD, these are not generally built in the motor, where we cannot use the RTD, resistance temperature detector, that is with the change in the temperature resistance changes, that if that is not there in the system, then in that very case we are actually using that. You can say we can use that in that very application. So we can also utilize this thermal relay. This thermal relay can also be used. Now that this can be also be used for the protection against overloading. Protection against overloading of generators, transformers, and induction motor and reactors also. So this is about this thermal relay. Let's have the quick recap of whatever we studied. First, it is thermal relay. We have the basic concept of thermal relay. It is based on the strain generated due to the unequal linear expansion. अनइक्वल लीनियर एक्सपेंशन की वजह से जो स्ट्रेन जनरेट होता है, हम क्या करते हैं, दो मेटल्स लेते हैं, उस मेटल से हम क्या करते हैं, एक का कोफिशिएंट ऑफ लीनियर एक्सपेंशन ज्यादा होता है एज कंपेयर टू अदर, एंड बिकॉज ऑफ दैट वन मेटल बेंड्स मोर एज कंपेयर टू अदर, एंड बिकॉज ऑफ दैट वो वर्क करता है. ठीक है. उसके बाद जिस तरह से सपोज ओवरलोडिंग और दिस फॉल्ट में क्या difference है, what is the difference between the overloading and the fault? So the difference is that in case of the fault the change is gradual, however in case of overloading that change is not gradual. ये धीरे धीरे ओवरलोडिंग के केस में वो धीरे धीरे चेंज होता है, और इसमें फॉल्ट में अब्रप्ट चेंज होता है, एकदम से चेंज होता है. उसके बाद ओवर यू कैन से दैट दिस जितना हमारा ओवरलोडिंग ज्यादा है उतनी कैपेबिलिटी, विथस्टैंड कैपेबिलिटी किसी इक्विपमेंट की वो कम हो जाएगी. देन वी विल हैव व्हाट इज द प्रॉब्लम विद द प्रॉब्लम क्या आती है हमारी इसमें ओवरलोडिंग के केस में. दिस थर्मल रिले अगर हम यूज करते हैं तो थर्मल रिले में रीसेटिंग टाइम है. सपोज हमें हमारा इक्विपमेंट है, कोई ट्रिप कर गया और एकदम से हमें स्टार्ट चाहिए, तो वो नहीं कर सकते. दैट इज द रीसेटिंग टाइम ऑफ दिस kind of relay is very large. So that's why nowadays we are using the thermal relay application in case of the digital or numerical relay. Then if you take the, if you compare, अगर compare करेंगे हम MCB को, MCB को, तो MCB में दो अंदर दो डिवाइसेस होती हैं, एक तो इंस्टेनियस डिवाइस एंड सेकंड बाईमेटेलिक स्ट्रिप. और एकदम से अगर चेंज होगा तो इंस्टेनियस डिवाइस जो है वर्क कर जाती है और एकदम से वो ट्रिप कर जाती है, और बायोमेटेलिक स्ट्रिप थर्मल रिले की तरह वर्क करती है. एंड एज यू नो दैट दिस इक्विलिब्रियम टेम्परेचर क्या होता है, हीट जनरेटेड होती है हीट डिसिपेटेड के बराबर. अगर हीट जनरेटेड और डिसिपेशन में डिफरेंस हो, इन दैट वेरी केस द heat will increase and it will affect our insulation, and insulation are different types like A to H type of insulation. And this is actually the graph between this time within which the temperature of equipment exceeds the temperature withstand value of the insulation or overload current. So इसमें ओवरलोड की हमेशा अगर आप कैरेक्टरिस्टिक्स की बात करो, then in that very case the equipment characteristics is this withstand equipment characteristics, and the relay characteristics, let us suppose here this one and this one. So we can have the relay characteristic हमारा ऐसा होना चाहिए ताकि वो equipment characteristics withstand कैरेक्टरिस्टिक्स के बिल्कुल पास हो, सो दैट हम उस कैपेबिलिटी तक उसको ले जा सकें. And you can say the overcurrent relay, why the overcurrent relay cannot be used for the overload protection? It is because that the overcurrent relay is the principle of overcurrent relay is different. It cannot we cannot take exploit the thermal characteristics of any this in that very case overcurrent relay, because the time in that very case is very large. उसमें time जो होता है हमारा बहुत कम होता है. And then we have the basic idea of that this relay, and then you have the applications of that. That is application, you can say that it is used for the low voltage and the low power rating induction motors and DC motors, protection against the overloading of generators, transformers, induction motors, and reactors also. Now, some of the questions that rises, yesterday one student told me that if you can give the view of different questions that an interviewer might ask related to the topic, then it would be good. So the question that a student can that any interviewer can ask, that what is thermal relay? Thermal relay, basic principle. So he can ask that question. Thermal relay, what is the basic principle of that thermal relay? Now, the second is that what is the difference between overload and fault? So, what might be the difference between this overload and the fault? Then you can also, after that, what we have discussed this. Okay, resetting time. Then he can ask that what is resetting time? Resetting time of relay, or you can say disadvantage of thermal relay or disadvantage of thermal relay for instantaneous operation. So then he can ask about MCB comparison of MCB and thermal relay Or he can ask in a different way how thermal relay is subset of MCB. How the thermal relay is contained in the MCB. Now we have discussed the characteristics that designing of the relay based on time overload characteristics. And you can say that how we can design thermal relay based on how we can design that particular thermal relay based on the equipment thermal characteristics. And we can ask about the why designing of the relay based on the this time over current characteristics, how we can design the thermal relay based on the equipment thermal characteristics, and why the overcurrent relay cannot be used for thermal applications. And then he can ask the basic construction of this thermal relay. And then very important question he can ask about the application, because application part every interviewer is asking, whether it is motor, DC generator. So application is the very important part. You must know the application, that whatever the type of equipment that you are studying, whether it is machine and everything, where the application, where its application is, where it is used. The application is very important. Now, any questions related to that?